Hello everybody. Today we're going to be looking at a topic called applications of quadratics. So we're going to have to follow a process to solve application questions of quadratics. And here I've given you a little guide as to how you can solve application questions involving quadratics. So step number one is to define a variable. That is to let x equal some unknown in the question. Step two would be to draw a diagram, if possible. Step three, write an equation from the information that we're given. Step four, solve the equation, which will include some sort of factorizing technique. So highest common factor, difference of two squares, the non-monic or monic trinomial factorization methods. And then finally in step five is choosing the solutions that make sense. So some quadratic equations will give two answers, and sometimes both answers will make sense. Other times only one answer might make sense. Okay, and I've given just an example here. If we get a negative number after we solve the equation, but we're trying to find the length of a paddock, we have to reject that answer because the length of a paddock can't be negative at all. So we do need to do a final check once we've solved the equation, whether to check which answers make sense or not. So example number one, let's have a look at some examples. When two consecutive whole numbers are multiplied together, the result is 20. Determine the numbers. So you might think, oh great, I can answer this problem straight away without even going through the 5-step process. And you're probably right in this case. So consecutive numbers mean one after the other. So you might think, oh, I know two numbers that multiply to give me 20 and they're consecutive, 4 and 5. Okay, then those numbers meet the condition. They're consecutive numbers and they multiply to give 20. Okay, but obviously we're here to look at how we could use quadratics to find the answer to this problem, and just to make sure that there's no other answers possible other than this. So let's have a look at how we could do this with quadratics. So in step number one is to let x equal something. So we can say let x be the first number. Okay. Now, if x is the first number, the next number after that, so a consecutive number, would be x plus 1, one more. Okay, just like if I have the number 3 and I want the next number, I can just add 1 to it to give me 4. So if x is the first number, x plus 1 is the second number. Okay, so I can write that down as well. X plus 1 is the second number. Okay, now it's not, so that's step number one, but it's not appropriate to draw a diagram in this problem. There's nothing actually to draw, so we can skip over step 2 and go to step 3, which is develop an equation. So we develop an equation by reading the problem again. It says when two consecutive whole numbers are multiplied together, the answer is 20. So we multiply our two numbers together, which is x times x plus 1. And we write that with brackets. X bracket x plus 1 equals 20. So there's our equation. So that's step number 3. Step number 4 is solve this equation. So the way we need to solve this equation in this case is we'll need to expand the brackets, which is x squared plus x equals 20. And then we will need to move the positive 20 from the right hand side, and we need to subtract 20 both sides. to give us this quadratic equation. X squared plus x minus 20 equals 0. And I now that it equals 0 on one of the sides, I can now try and solve this equation. Okay, so I use a factorizing technique. So this has got 3 terms. So it is actually a quadratic trinomial, and it's a monic trinomial. So just on the right hand side, we actually need 2 numbers that multiply to give negative 20, and the numbers need to add to give 1, which is the number that's in front of the x. So we just need to think about that. What would our 2 numbers be here? So it would be 5 and negative 4. Okay, there are 2 numbers. So I come back to the quadratic and I factorize that by writing that in a set of brackets. X plus 5 bracket x minus 4 equals 0. Okay, now I use the null factor law. Which tells me if I'm multiplying 2 numbers together and the answer is a 0, one of the brackets or both of the brackets have to be a 0. So I write x plus 5 could be a 0, or x minus 4 could be a 0. Solve each of those equations separately to give me x equals minus 5 or x equals positive 4. Okay, so that's step 4. Solve the equation. Step number 5 is just look at the answers and check whether they both make sense. So let's look at x equals 4. So remember, x is the first number. Okay, so would that make sense? If the first number is 4, the second number is 5. It's a consecutive number. It's x plus 1, so it's 5. So yes, numbers are 4 and 5. But let's check the other answer. So if x was a minus 5, okay, then so minus 5. If I was to add 1 to that number, because adding 1 gives me the second number, minus 5 plus 1 is minus 4. So would these 2 numbers make sense? Would minus 5 and minus 4 be a correct answer to this problem? So if I was to multiply minus 4 and minus 5, does it give me positive 20? Yes, it does. And are they consecutive numbers? Yes, they are. So there's actually 2 sets of numbers here that make sense for this problem. So positive 4 and positive 5 is one set of numbers that work, and negative 5 and negative 4 is another set of numbers that work. So both of those answers are correct. Okay, so our initial thought up here, the numbers being 4 and 5, well, yes, that was one set of correct numbers, but there actually was another set of numbers that worked as well. And it meets the condition, they're whole numbers. Okay, so that's problem number 1. Problem number 2. The area of a rectangle is fixed at 48 meters squared, and its length is 2 meters more than its width. Find the dimensions of the rectangle. So the dimensions of a rectangle just mean what's the length and what's the width. So step number 1 is to let x be something. There must be some unknown in this problem. So if we read it again, we actually know what the area is. It's 48. And the length is 2 meters more than the width. So the width, we have no clue about what the width is. We're not told anything about the width. So that's a perfect variable to use for the width. So I'm going to say let x be the width of the rectangle. Okay, that's our unknown. Step 2, draw a diagram, if that's possible. So in this case, it is possible to actually draw a diagram. So it's suitable. It's a suitable problem to draw a diagram. So here's my rectangle. And now I mark in what I know. So the width is x. So I'll put x's on the width. And I'm told that the length is 2 meters more than the width. 2 meters more just means to add 2. So x plus 2. So the length is x plus 2. Okay, so that's step 2. Step 3 now is to write an equation. So the equation would be area equals length times width. Okay. And we actually know what the length is. So the length is x plus 2 multiplied by the width, which is x. Okay. We're also told that the area is 48. So instead of writing A for area, I'll write 48 equals x plus 2 all multiplied by x. That's step 3. So there's the equation. Step number 4 is solve that equation. Okay. So I will need, again, I will need to expand the brackets. So 48 equals x squared plus 2x. I will need to move the 48 over to the right side by subtracting 48. So that will give me 0 equals x squared plus 2x minus 48. And now that it equals 0, I can now solve that equation using some sort of factorizing technique. So have a look at the quadratic. It's 3 terms, so it's a trinomial. The number in front of x squared is 1, so it's monic. Okay, so I'm going to need to find 2 numbers that multiply to give negative 48. And those numbers have to add up to give positive 2. Okay, so I've got to think hard about numbers that multiply to give 48. You got 12 and 4. 6 and 8 is a good pair because 6 and 8 are 2 units apart. So we'd go 8 and minus 6 are our 2 numbers. If I multiply them together, I do get negative 48. If I add them together, I get positive 2. So coming back to the quadratic, I can now factorize. 0 equals, now I factorize the quadratic, x plus 8 in one bracket, x minus 6 in the other bracket. Now I use the null factor law, which tells me that if 2 things are getting multiplied and the answer is a 0, one or both of those things must be 0. So one of the brackets, x plus 8 equals 0, or the other bracket would equal 0. So that's x plus 8 equals 0, or x minus 6 equals 0. Solve these equations for x. Would give me x equals minus 8, or x equals positive 6. Okay, so there's the 2 answers. Now step number 5 is to check which solutions actually make sense. Do both answers make sense? Do no answers make sense? Or does one of the answers make sense only? So remember what we're trying to figure out here. We're trying to, x is the width of a rectangle. So could the width of a rectangle be negative 8 meters? No, that doesn't make sense to have a length that's negative. But could it be 6 meters? Yes, it could. So x equals 6, okay, is the suitable solution. It's the only suitable one. The negative number doesn't make sense. Okay, so now we need to answer the problem. The problem is find the dimensions of the rectangle. So the width equals 6 meters because that's what x is. X is the width, and we just found x equals 6, and the length is the width plus an extra 2 meters. So 6 plus 2 equals 8 meters. So there's our final answer. The width is 6 meters, the length is 8 meters. So you can see how we've used quadratics to represent this problem and use our factorization techniques to solve the equation and to find an answer to the problem. And our final problem is problem number 3, which says the height of a footballer after being kicked is determined by the formula h equals negative 0.1 d squared plus 3d, where d is the horizontal distance from the player. How far away is the ball from the player when it hits the ground? And then part B, what horizontal distance has the ball traveled when it first reaches a height of 20 meters? So for this problem here, we don't have to do step number 1 and let x equal something, because they've already given us the equation. So they've already done step 3 for us in this case as well. Okay. They've given us an equation. They've told us what the letters actually mean. Okay. The h is the height of the football and the d is the distance. Okay. That the football is from the player once they kick it. But we could draw a little diagram of the situation to help us understand what's happening here. So this dot here is, I'll just say P is the player. Okay, so they kick a football in the air. Okay, now, so basically we want it to look something like this. Okay, the ball goes up, 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 and then it'll eventually come back down and hit the ground over here. Okay, and it reaches a certain height. So I'm almost going to draw like an axis here, h, and across here is the distance. Okay, so the football goes up and then it will eventually come back down to the ground. So the part A asks for how far away is the ball from the player when it hits the ground. Okay, so it's going to hit the ground at this dot here, this large dot on the right. Okay, but we need to understand the coordinate, the Cartesian plane here. Okay, if we think about that as a coordinate point right there, okay, it's some sort of distance, comma, and because it's on the ground, the ball's on the ground, the height would be 0. Okay, the height is 0 if it's on the ground. So I can go back to my formula that they give me and I can make the height 0. Okay, so I could actually say for part A, when the ball's on the ground, the height is 0. That should make sense to everybody. So now I go back to the equation and I will say 0 equals negative 0.1 d squared plus 3d. And what I need to do is find the distance, d. Okay. So to solve this quadratic equation, again, I will need to do some sort of factorizing technique. So the best technique to use to factorize this would be just highest common factor. Both equations have a d that's common. So d bracket negative 0.1 d plus 3, and that all equals 0. So it's just a HCF method here to factorize. Now, because I've factorized it and it equals 0, I can actually use the null factor law. Okay, as I've used in the previous examples. Okay, and basically, so the null factor law says that these two things that are being multiplied together, one or both of them could be 0. So that would be d equals 0, or negative 0.1d plus 3 equals 0. So our job here is to solve both of these equations. So the one on the left is already solved for us. It says d equals 0. Can't do anything with that. But we can solve the second equation. So that's a linear equation. I can subtract 3 from both sides, which gives me negative 0.1d equals minus 3. And I can divide both sides by negative 0.1. So it's negative 3 divided by negative 0.1. So negative divided by a negative is positive, and 3 divided by 0.1, if we did that on a calculator, would give us 30. You can check that on your calculator if you'd like. So I'll just do that here. Negative 3 divided by negative 0.1, just to confirm that it's 30. Okay, so this is 30 meters. The question is, how far is the ball away from the player when it hits the ground? So the answer would be 30 meters. Okay, so I've got two answers. Why have I got two answers? Because I've got an answer over here where the player actually is. Okay, there's one answer because the ball's on the ground right there, or at ground level, and then it's at ground level again after 30 meters. Okay, so my final answer would be the ball is 30 meters away from the player. Just to interpret what our answer actually means. Okay, so the ball is 30 meters away from the player. So that's the answer to part A. Part B. What horizontal distance has the ball traveled when it first reaches a height of 20 meters? Okay. So this is a height of 20 meters. So that's somewhere up here. So in my blue pen here, so 20 meters somewhere up here. So what you'll notice is if I draw a line straight through this graph, the ball reaches 20 meters twice, somewhere here and then somewhere over here. Okay, but it asks for when it first reaches. So that's this first dot here. Okay, so this question mark I'm putting there, that's the distance that I need to find. The first time it reaches a height of 20 meters. All right, so what I'm told is I know h equals 20. That's what I'm told. Okay, h equals 20. So I substitute that number into my equation. Okay, into the formula that I'm given. So for part B, okay, I'm told that h should be 20. So when I substitute that number into the equation, I'll get 20 equals negative 0.1 d squared plus 3d. Okay, so again, I need to solve this equation, but to do that, I need it to have a 0 on one side. So I subtract 20 both sides. And I'm going to be left with a quadratic equation that says negative 0.1 d squared plus 3d take away 20 equals 0. Okay, so now I need to think about the only way I can solve this is to factorize it. And then I can use the null factor law. This is a non-monic quadratic trinomial. Okay, because the number in front of the squared term is something different to the number 1. It's a negative 0.1. So just on the side here, remember to do the non-monic, it's good to write down what the A and the B and the C are. So A is negative 0.1, B is 3, and the C is minus 20. And we need to figure out what AC is, which is negative 0.1 times negative 20, which is positive 2, if I was to do that multiplication. So I'm actually looking for two numbers that multiply to give 2. And they've got to add up to give 3. Okay, so those two numbers would be 2 and 1. 1 and 2. So I can factorize a quadratic. So remember, to factorize this quadratic, we have to use the grouping method. So it's negative 0.1 d squared, and instead of writing the 3d, I write plus d plus 2d. So I separate the middle term. Okay, separate the middle term. Okay, that's how the process for the non-monic works. So we're splitting up the middle term, and now I need to use the grouping method. So I've got 4 different terms. I need to use the grouping method. So I can just group the first 2 terms and the last 2 terms. The first 2 terms have a d in common. The last 2 terms have a 2 that's in common. Okay, so 0 equals, if I factorize with a d, I'll have d bracket negative 0.1 d plus 1. And for the second bracket, there's a 2 that's common. So 2 bracket d minus 10. Okay, and I realize here that my brackets are different. These 2 brackets should be the same. Okay, and then I can factorize again, but they're not the same, which means I haven't done anything wrong. I just need to do something a bit different, and the problem is because of that decimal number. Okay, you see the number in front of the d in the second bracket is a 1, but the number in front of this d in the other bracket is negative 0.1. So I will need to take out the negative 0.1. That will need to come out. So I will need to take the negative 0.1 out, as well as the d that's already out. So negative 0.1 d bracket. Now, if that negative 0.1 comes out, I'm just left with a d, a positive d, which is great. And because I've taken out a negative number, I have to change the sign of this one here. So this was a plus 1, it will become a minus. Okay, and then thinking about this is it's a little bit more challenging. If I take a 0.1 out of the number 1, it will actually be a 10. So think about this. Think about doing the multiplication. What's 10 times 0.1? Well, that will give me the number 1. Okay, so you can double check that if you want to clarify. 0.1 times 10 gives you the number 1. Okay, so that's the correct factorization there. And then you'll see now that that's now the same. We have the same set of brackets. Okay, the same brackets, a d minus 10. So Now d minus 10 is common, so d minus 10 goes in one bracket, and the other bracket is negative 0.1 d plus 2. That's the leftovers. Okay. Now I can use the null factor law, which is the NFL for short. And that says each bracket could be 0. So d minus 10 equals 0, or negative 0.1 d plus 2 equals 0. From the first equation, I will get d equals 10. And if I solve the second equation, so I need to subtract 2, and then I need to divide the negative 2 by a negative 0.1, which will end up being 20. If you want to check the arithmetic, you can. So negative 2 divided by negative 0.1 gives me 20. Okay, so they're my two answers. So the distance is 10 or 20 meters. If I go back to the problem up here, look at my blue. So this one's 10, the first time is 10, and the second time is 20. And the question asks for when does the ball first reach a height of 20? So that's after 10 meters. 20 is further down here. So the answer, final answer, would be D equals 10 meters. Okay, so this is a slightly different problem to the first two, but still goes through some of that process outlined on the first page. So we're still dealing with an equation. We still have to solve an equation and use our factorizing techniques to do that, to answer the problem here.